Hello everyone and welcome to another episode of Noir Yudarris. This is your host Mahmoud Noir. Today we'll be talking about states and state functions in thermochemistry. We're going to be speaking about the conditions and the physical changes that a certain substance goes, for instance, from a solid to a liquid, or from a liquid to a gas, etc., etc. Please don't forget to like, share, and subscribe. And shall we start? Physical changes affect the intramolecular forces. Usually when you're changing phases, you're either um, breaking intramolecular forces or rejoining them together. The higher the kinetic energy, the higher the entropy, means the more randomness will occur. So an example, an ice cube undergoes fusion, means melting, goes into a liquid, and then the liquid undergoes vaporization, and then this vaporization results in a gas, thus increasing as kinetic energy increases, entropy increases. There's a lot of randomness because there's a high level of kinetic energy, there's a high level of randomness. But then when gas condenses into a liquid and then a liquid crystallizes into a solid, heat is released because bonds are formed. So when bonds are how would I say this? This is an endothermic reaction. So a fusion is an endothermic reaction, vaporization is endothermic because you're putting in energy in order to change the state of the um, substance. And then these transitions require heat, and then they're called the heat of transition. So for instance, heat of fusion is the amount of heat to melt the solid into liquid. Heat of vaporization is the amount of heat to vaporize liquid into gas. And then Q is the heat, and it's calculated using moles times the delta H, which is enthalpy. Alright, so if enthalpy is positive, means heat is absorbed. If enthalpy is negative, it means bonds are formed and heat is released. When temperature changes, it uses Q equal MC delta T, or MCAT. Okay, when phase changes, it uses Q equal M molarity times delta H, which is enthalpy. And the specific heat of substance depends on the phase. There's a lot of phases. Next, you have supercritical fluid, which is a substance that's past the critical point and displays the properties of both gas and liquid. HO phase diagram, which is on the right above the triple point. You can see the ice temperature. It goes from the solid to liquid to gas. Alright, so you got the solid, liquid, and then you got the gas here, and this is the critical point. And then the CO2 phase diagram, as you increase pressure, the density of the material increases. So you go from solid to liquid, and then the triple point is where all three meet, the solid, liquid, and gas. And that's it for the state and the state functions. Please let me know if you have any questions, and yeah.